So read it. Okay? All right. Observational study or experiment and explain, please. Explain to me as you would explain it on the AP test.
This experiment is experimental. Wait.
This is an experiment because
music treatments were imposed.
the music treatments were imposed. Would be great. Something in context, okay? And what's our response variable here?
Homework.
Did they actually complete the assignment or not? Okay. And what controls did Miss Meister make up when she made up this experiment?
Similar academic achievement.
So the sample was all kids who all had about the same academic achievement, okay? So it wouldn't be like one group, like the classical group has more smart kids in it, right? Or fast workers, or however you want to call it, okay? What else?
All 15 minutes.
They all had the same amount of time.
They all had the same assignment.
They all had the exact same assignment. What other controls do you think we could consider?
The same assignment? No? Okay.
Classroom, like
They were all in a similar room, for sure. How many of you guys can get distracted in one room but not another? Sure. Okay. Same time of day. Like, I don't know about you guys, but 5th and 6th period is always my least productive class times of the day. Right after lunch is always the worst time to have a class. Doesn't matter what. Think about your 5th period class. Nobody's focused coming back from lunch. And 6th period is when the food coma really hits. When you start to get the nods, that full belly, and all you want to do is take a nap. 8th period's always my least focused class period. Yes, yes.
I'm like really confused right now. But like,
First period is also bad.
like I know what's happening, but like after 8th period, I'm like done.
My first period.
And then we have
7th period. Chem is the only time I've ever really focused.
3rd period has always been a fairly good class period. Like, I've never had a bad class during 3rd period. But, like, 8th period is rough. 6th period is rough.
You know, I just think the whole school day is rough. Like,
Yeah.
I can get behind that.
Did you say art class today, bro?
You guys are one of my least focused groups, yes.
yes, but think of how productive we are.
Yeah.
It's arguable. So, why did I have a group that did not listen to any music?
So you could determine causation.
Well, I can get cause and effect between just the two groups. So what does the control group do?
You can compare results.
To general population.
The control group kind of gives us a baseline. They're still not general population because all the kids are the same. A baseline of no music, of just basic assignment completion. How many of these kids were going to complete this assignment either way, despite music? Okay? All right. And if I were to ask you guys, what is the probability that a person completes the assignment, what would you say? Are you guys cool if I call that? I'm going to go ahead and label the two-way table with the letters J, C, and N for those events. And then I'm going to call it finished and not finished. I don't want to use C again, if you know what I mean. But, like, on the AP exam, if you chose a different set of letters to describe these, that's cool, too. All right? So just in general, what is the probability a randomly selected person finishes the assignment? 80 out of 150. It's going to be a little bit more than 50%. I'm sorry? 0.53 repeating. Yeah. And if you put 533, that's fine. Okay? All right. What if I said, what if What is the probability of a person who listened to the jazz? So given that they listened to jazz music, what is the probability that they completed the assignment? All right. So, overall, are the events completing the assignment independent and listening to jazz music independent?
I don't know. They're like so close. It's like
For right now. For right now. For this sample. Within just this sample, are they independent? No. Our rule for independence is that the probability of A has to equal the probability of B. Oh, wait, that was totally wrong. Well, so two events are independent if the probability of A is equal to the probability of A, given that B has occurred. Both of them are the probability of A. It's the, if I know B has occurred, can we say that A is, the probability of A has changed? Okay? And in this case, technically, it has. But on a technicality base. Is everybody comfortable with that idea? However, 0.51 repeating, 0.53 repeating, are they really that different from each other?
No.
And in fact, if we were to take a different sample of 100 kids and give 150 kids and randomly assign them into these treatment groups, would we get a different answer?
Yeah.
Okay. So we still have this we still have this kind of like funky, could it have happened by chance thing. But now what we did is we say, all right, there were always going to be 53% of the kids in this group that were going to complete the assignment, right? And we randomly assign them to the treatment groups. So could the differences that happen here have occurred by chance instead of by, that's our goal, is, is every group going to be exactly 53.3%? Probably not. Could the differences that we see have occurred by chance? That's going to be the end of that goal of this new kind of test that we're going to learn. Today, we're not going to get that far with it. Tomorrow, we'll get real far with it. Cool? All right. Ooh, we haven't done this in a really long time. All right. So basically, find the conditional distribution of the assignment completion for each treatment group. So in other words, for the jazz group, y'all, what percent completed the assignment for jazz?
0.51. Or
Yep.
everyone.
And then and what percent there did not complete?
0.48.
Okay. Well, the two of them, if it rounded to 0.51, it should also round to 0.49. Because it would have rounded to 0.48 repeated? No. It should have been 0.49. 0.48 repeating.
Yeah, that's 49.
Okay. And then if we did the same thing for the classical group, we would do 31 out of 54.
0.57.
And then this one should be 0.43. And if we did the same thing for the no music group,
0.51.
everybody good so far? And if I asked you to just describe what you see there, we might say, hey, The classical group definitely had a higher percentage, right? Is that a meaningful percentage?
I don't know.
I don't know. Could we draw a graph of this? What this tells us?
Yes.
What kind of graph you guys want to draw?
Maybe
Bar
the 3
graph.
bars,
But, like,
and then
the-
on the one side is the percentages, and you can shade in the parts of.
Yeah. Oh, yeah, I know what you're talking about. That made a lot of
Does anybody remember the name of that graph?
No,
no.
It's not a histogram.
It is not a histogram. That is an accurate assessment.
And like a,
I don't know. I know how to do it.
I know how to do it too. It's like 3 bars, and you split it in half, you shade one. So
Segmented bar graph.
It is a segmented bar graph.
Hold on, I need room to.
We were
draw
just
this.
testing you.
Thank God. Thank God I have you guys to keep me on track, you know?
I know, right? We're so helpful.
Oh man, that looks bad. Now, why did we have to do all of these in percentages?
Because the numbers are different.
Because I can't directly compare this 31 to this 23. Because the 31 is a bigger size group to begin with. Does that make sense? All right. Now, guys, tell me some things that are wrong with my segmented bar graph right now.
It's not like shaded.
We're not seeing many differences amongst these bars right now, are we? All right. So, 51, that's slightly above. Now, you guys said shaded. I'm going to go ahead and say complete, not complete. It doesn't really matter. If you do the shading, just make sure you communicate that somehow. Now, as we go to do these next ones, guys, it doesn't even matter if you do complete on the bottom. What matters is that you're always consistent, okay, that they go in the same order. So since I started with complete on the bottom, I'm going to keep complete on the bottom. And then do the same thing for the red graph. Now, I don't think you guys will be asked to create a graph on the AP exam. I don't. It's happened 3 times in the past 20 years. Okay, so in the past 120 questions, 3 of them have been make a graph. It's not very likely, okay? Reading these is probably more important. However, let's go ahead and say I asked you to create a graph. Can somebody tell me why this graph would get a P instead of an E? Doesn't need a title. What was our response variable here?
Oh, music treatments.
No, that was our explanatory variable. But we might want to say the music treatments are down here.
Yeah.
And we need to have labels on our axes explaining the context.
And then that's how we do percentages of homework completed.
Proportion of assignment completion. The reason I point this out, guys, is, and I didn't take any points off for anybody for this, but on the quiz that you guys took on Friday, a lot of people were a little bit lazy in the way they did their communication on context, particularly in the last question. I circled the context you should have included and kind of drew an arrow when you get those back. I'm sorry?
Can I get those back after this one?
if I remember past them out, I'm going to prioritize notes, but yeah. Okay, and the biggest piece is when you can include more context, you should include more context. Okay, don't use one word when 5 will do. Cool. All right. So I think we're good to flip the page. So all right. So if I want to know what percent of the assignments were actually completed, we already did this. It's going to be 80 out of 150, right? So so when we do our expected counts, we're going to write, this is going to lead into a chi-square test for a two-way table, okay? And so when we do our expected counts, those are what our null hypothesis is, which is going to be there's no relationship between the two variables. So if I want to know if the two variables are independent, that's a huge if, okay? Huge. If the two variables are independent, then how many should I have expected in each one? Well, so let's kind of think that through for a second. If I'm in this column, right? If I'm in the jazz column and I'm calculating my expected count, okay? I want to know what out of 45 is going to equal 80 out of 150 because I want the probabilities to be the same. So what out of 45 equals 80 out of 150, y'all? And what process are we doing to get that? Yeah, so are you with me that you're going to end up doing 40 times 80 out of 150? Is that okay? Well, 40 times 80, that was essentially the column total times the row total divided by the table total. And that's what's going to keep, and it's always going to be, so for the next one I'm going to do 80 out of 150 equals what out of 54? And I'm going to do the exact same process every time. All right? So, and then typically what we do with these, by the way, what was the answer to that? 24? And so that would make this one 21. Typically what we do is we put the expected counts in parentheses next to the actual observed counts. Is this okay? And then, so we've got 20, and then what about for the classical? So now, to do the classical, I'm going to do 80 out of 150 has to equal what out of 54? Another way I could do that is 54 times 80 out of 150. You with me? So that's still row total times column total, all divided by the table total. And what are you getting there? 28.8. Perfect. And that would leave this one to be, let's see, this is down by 2.2, so up by 25.2. And then we do the same thing for the no music group. So that would be 80 times 51 over 150.
27.2.
Making this one 23.8. How is everybody feeling so far? Emma, are you still mad at me?
No. You explained it a lot better than Mr. Roberts.
Well, I teach math for a living. All right. Well, hold on. Now that we have observed and expected counts, could we do the sum of O minus E, the quantity squared, all divided by E? Could we do that for each square? We could. So here's what we're going to do. You three, can you guys do the orange ones? The jazz group? And then you three, you guys know who I'm talking to, right? Yeah. Can you guys do classical? And then seniors, can you guys do the no music group? You guys split up pretty nicely here.
0 minus expected, so it should be whole number minus a non-whole number.
How do you do the second? How do you do the first?
Guys, how am I doing on these?
Good.
Oh, could you do 34 to the third one?
All right, and what should I do with all of those numbers to calculate chi-squared? Lots of addition. Do you guys wanna?
Yeah. Now I did 2, I just
So we're literally adding all 6 of these together. Guys, do you think I'm gonna make you do this by hand?
No, by now.
But do you see? Sabrina, I'm hurt by that. How often do I make you do calculations like this by hand?
I mean, like sometimes, like.
As an introduction to show you where it's coming from, yes. I always show you what your calculator's doing, but then I show you a calculator shortcut. All right, let me, I'm going to cheat real quick, if you guys are okay with that.
Feel better. You're cold. No. It's like, yeah. It usually helps.
Guys, when I added all these up, I got chi-squared equals 0.562.
Yes.
It's really low. It's really low. All right, so we just essentially assumed that the two events were independent, right? The two variables were independent from each other. That's how we got. And we're essentially talking about null hypothesis is that there's no relationship between our two variables. Our alternative is going to be there is a relationship between our two variables. And then we're going to run a chi-square test. So there are 3 conditions for a chi-square test of independence or a chi-square test of homogeneity. We'll talk about like why we have 2 different names. They're both run the exact same way. We'll talk about that tomorrow. Is anybody shocked to see that the conditions we're dealing with are random, large sample size, and independence?
I'm shocked.
Okay. Don't lean back.
Well, that's too easy of a solution.
No, it's the best solution. Stop leaning, please. All right, so the random, you're going to check same as always. The independent, you're going to check same as always. The independent, does anybody want to guess? Or I'm sorry, the large sample size condition, does anybody want to guess what that is?
Under 5. I mean, less than, greater than 5.
Hey guys, are all of our expecteds greater than or equal to 5 here?
Yes.
All right. So, our degrees of freedom is a little bit different for these, okay? It's the rows minus 1 times the columns minus 1. And when we talk about these, guys, the data table here is only these 6 numbers, okay? The rest of these are summaries of what these 6 numbers are telling us. So you don't include the totals here. All right, so if I do that, how many rows do I have?
1 or 2.
2 minus 1, okay? And how many columns do I have?
3.
3 minus 1. So what is the degrees of freedom for this particular table? 2.
You're multiplying them. Yeah.
So 2 minus 1 is 1 times 3 minus 1 is 2.
Oh, so it's only take the middle rows, right? Like the ones like in there.
You do your rows minus 1 times your columns minus 1.
Yeah. But you just like exclude the totals.
Yes. All right, hold on. Wait a minute. Does this mean, shouldn't we be able to calculate a p-value then?
It does.
Yeah, we have that chi-squared CDF. So we have a chi-squared graph is skewed right. We have 2 degrees of freedom. Our chi-squared value is 0.562. And we can go ahead and shade to the right, because chi-squared is always shaded to the right. And you can actually do chi-squared CDF.
Wait, what's the lower? Oh, wait, the 0.5. The lower is. I got 0.754.
Hey, so did I.
Fantastic. I got 0.755. Well, I used a more exact value.
I bet you didn't.
I used 0.5629.
Fair enough. I got 0.7547.
What's the test thing?
Don't worry about that. You're using chi-squared CDF in the distributions menu
Oh.
for right now. I'll show you guys how to put this in a second.
Yeah, that's
I really like your summation sign. It's nice there.
Thank you.
I feel like it should go in like Miss Lombardi's worst things ever.
Oh no.
That's not nice.
The worst things ever, best.
That was like hurtful.
Wait, so that was a compliment, but not at all.
Exactly. That was like that was definitely a backhanded compliment.
She was like backhanded.
Yeah. Okay. So, how do I have? Yeah, I don't want to talk about that today. Why don't we finish up with how do we put this in the calculator? Okay.
Wow, guys.
All right. We have to use something that you learned in pre-calc.
It's an automatic, we don't remember.
That's not true. It's not hard. Okay.
Is it like matrices?
It is in fact a matrix. That's exactly what you have to do.
I didn't
No,
know that.
you were the only person who did good. She led the correct
That's a
part.
lot of anger.
It was
Okay.
I understood that unit. Oh my gosh. It's like you have to calculate those ones.
That was the one.
That was the worst.
I got like a 90 on
Ever.
it, but I got 100 in my calculator.
I got like a 95. I studied and I
did corrections on that because she gave corrections. Everyone did so well.
Remember that time I said that you guys are one of my most unfocused classes?
I can't believe I
What I meant was
Exactly.
this precise moment. Okay. So what you're going to do, guys, is you're going to look at, you don't have to do any calculations with the matrices. You just have to give the matrix to the calculator, okay? Because it's important to the calculator that you keep the rows and the columns in rows and columns. So here's our matrix.
It's really not all that bad. I just didn't really like. I figured how to do this.
Okay. Now, so just like before, we had to edit our list. What we need to do is edit our matrix. Okay? So let me go ahead and get my calculator showing. No, that's not how I want to do it because Ryan won't be able to see it. I want to do the video. And let's do that. Okay. Can you guys see this?
Yes.
Okay. So, how do I edit my matrix? Well, the first thing I need to do is bring up the matrix menu. I am not going to tell you how to bring up the matrix menu.
Second math.
No,
that's too much.
Do you see the word matrix right here?
No, literally.
Oh.
Okay.
Not bad.
Here's what you need to do next. You need to go over to edit and pick edit. You have to make sure you go over to the edit. That's going to be what you guys are going to screw up over and over and over again.
She didn't teach us.
She
Yeah,
didn't
you
tell
did.
us.
She taught us this. Did you not know? She taught us.
No, I don't
right.
remember this.
The next thing you need to do is make the matrix on your calculator match the matrix on your paper. So, this has 2 rows by 3 columns. Hey guys, if you screw that up and end up doing 3 rows by 2 columns, you can go back up and change them. So if you accidentally put them in the wrong order, I don't care. Just fix it. Is everybody okay with me?
Yeah.
have anger.
I have anger?
Passive aggressiveness.
I'll give you some anger. All right. Go ahead and type your data in here. You're going to do 23, 31, 26, 21, 23.
No, it's not 21. 21's expected.
Thank you. I'll fix it.
It's 22.
Thank you.
What? Wait, hold on.
I had this should have been a 22. I copied my expected count instead of mine.
So true.
Now, from there, you're going to go ahead and hit, does everybody have it in? You hit enter. Go ahead and hit stat and go over to tests. Now, we are going to do the chi-square test. It's not going to be the goodness of fit test because this is a two-way table. And goodness of fit goes on one variable, like type of candy bar. It wasn't type of candy bar and calories. Now, once you select chi-square test, it's going to say, where did you put the observed values? You're going to say, oh, I put them in matrix A. That second piece is not saying, where did you put the expected values? It's the calculator saying, where would you like me to store your expected values after I run the test? So here's what that means. So go ahead and hit down. Notice you guys have not put in the expected counts in your calculator. Is everybody right?
Yeah.
Okay. Go ahead and hit calculate. You'll have your value for chi-squared. You have your p-value. It even tells you the degrees of freedom.
Oh, my calculator isn't in the right. It said error domain.
Well, you put in the expected counts, maybe?
No, I don't think so.
Wow, are you making a problem?
Time passes so fast in this class. What was I at today?
I don't know. Where'd it go? You don't have a matrix, sir. I didn't know what else to tell you.
Okay, I had some sort of matrix.
So there's no way it would let you do a chi-square test on negative values because it's a count of how many things happen. They can't be negative.
Is it in names or edit? Wait.
No,
but like, where am I supposed to go?
go over to edit.
Okay.
Hit enter.
Okay.
Okay. Now, we ran the test, yes? Everybody go back to that matrix menu for a second. Go over to edit and go down to matrix B.
Wow.
It puts all the
Emma's.
expected counts in there for you. Now, I want you to envision someone grading your AP test. Are they going to know that you checked your condition before you ran your calculations?
No.
Is everybody with me? So you're going to go ahead and run the test almost first, okay? Then you'll go through and do we'll do the hypotheses and run the test so that you know, and then we'll go through and check your conditions so that we don't have to calculate all of those expected counts by hand. It's still going to be a pain that you have to write them all down because you have to write them all down as justification for greater than. How do you know they're greater than or equal to 5 if you don't know what they are? Is everybody with me? Okay. Now the other thing I want to point out is nowhere on your calculator do you see the contributions to chi-squared. If they're going to ask you about this, it's possible they will give you like you know how they sometimes give like a computer printout of results where they will have the observed, expected, and then they'll have one more number underneath it. That one more number underneath it is the contribution to chi-squared. Everybody good? What do you guys think about this? Was this, other than being a slight pain in the butt, with some practice, does this feel reasonable?
Yeah.
All right. We'll go into the nitty-gritty a little bit more mañana.
I definitely edited.